You know, we talk a lot about the incredible challenge of getting astronauts to Mars, but have you ever thought about how we get them back? Turns out, that might be the even harder part, and it all boils down to one single thing: fuel. So let's dig into how we're going to solve that.
Okay, so take a look at this. This is the dream, right? A human base on Mars. And this vision, it's getting closer and closer to being real. But there's this one giant problem we have to solve to make it happen for the long haul. Once we've got our astronauts on the red planet, how in the world do we get them home?
All right, let's talk about the problem. And honestly, it all comes down to weight. A lot of weight. It's such a logistical nightmare that engineers have a name for it: the 30-ton problem. And believe me, this is the biggest hurdle standing in the way of a round-trip ticket to Mars.
Yep, 30 metric tons. Think about that for a second. To get a crew off the Martian ground and point them back towards Earth, their rocket, the Mars Ascent Vehicle, needs 30 tons of propellant. That is literally the weight of 5 full-grown elephants. Trying to launch all that fuel from Earth, haul it all the way to Mars just to use it for the trip back. It's pretty much impossible.
So that leads us to the billion-dollar question, doesn't it? How on earth do you refuel a rocket when you're 140 million miles away from the nearest gas station?
Well, the answer is actually an idea that's as old as humanity itself. You don't pack everything you need for the whole trip. You live off the land. And in the world of space exploration, this totally revolutionary idea has its own cool name. It's called in situ resource utilization, or for short, ISRU. And the concept is actually pretty simple when you think about it. Instead of lugging every single thing from Earth, we're going to use what's already there, on Mars. We're talking about the soil, the water ice, even the thin Martian air to make what we need right on site.
Yeah, you heard that right. The solution basically is to build a gas station on Mars. I mean, how cool is that? With this, we stop being just visitors. We'd actually be using Martian resources to fuel up for the ride home.
And look, this isn't just some sci-fi fantasy. NASA engineers have already drawn up a super detailed blueprint for exactly this: a Martian fuel factory. So let's get into the nuts and bolts of how this thing would actually work.
Okay, so this schematic right here is from a real NASA study, and it shows the whole process from start to finish. I know, it looks a little intense, right? But what you're really looking at is a brilliant recipe for turning Martian air and dirt into honest-to-goodness rocket fuel.
Let's break it down. It really happens in 5 main steps. First, you've got a rover that's basically mining the ground for water ice. At the same time, another system is sucking in that thin Martian air to get the carbon dioxide. Step 3, you use a process called electrolysis to split that water into hydrogen and oxygen. Then, and this is the cool part, you combine that hydrogen with the CO2 to make methane fuel. And finally, you just liquefy the methane and the oxygen and store them up for launch day.
So, that chemical magic I mentioned, it all happens in step 4, thanks to something called the Sabatier reaction. You take the CO2 from the air, you mix it with the hydrogen from the water, and presto, you get 2 super useful things: methane, which is your fuel, and more water, which you can just feed right back into the system to make even more fuel. It's an incredibly slick and efficient cycle.
Okay, so this all sounds amazing on paper, right? But the big question is, does it actually work on Mars? Well, guess what? We have proof. A really, really important piece of this puzzle has already been tested, for real, on the red planet.
Say hello to Moxie. It's this little gold toaster-sized box riding on the Perseverance rover. The full name is a mouthful: the Mars Oxygen In Situ Resource Utilization Experiment. But its job is super focused: prove that we can pull oxygen right out of the thin Martian air, a key ingredient for our fuel.
And guess what? It totally worked. By the end of its first year on Mars, Moxie had cranked out pure oxygen 7 different times. It did it during different seasons, different times a day. It just kept working. This was the proof we needed that a huge piece of this ISRU puzzle isn't just possible, it's actually reliable.
The team that built it called it exactly what it was, and I quote, "the first demonstration of ISRU on another planet." Just think about that. This is a massive historic achievement. This is the moment science fiction officially became science fact.
So let's bring this all back to that 30-ton problem we started with. We've got the blueprint, we've got the proof that it works. So what's the ultimate payoff here? Why is this such a big deal?
This chart says it all. It's an absolute game changer. Instead of launching 30 metric tons of fuel from Earth, we only have to launch the fuel factory itself, which weighs just 1.7 tons.
Let that sink in. We trade 30 tons of cargo for less than 2. That is how you make a round trip to Mars actually happen.
Oh, and get this, there's a bonus. The whole process is so efficient that even after making all the fuel you need, the system has created a leftover stash of over 5,000 kilograms of pure oxygen. And you can bet the astronauts will be happy to have all that extra breathable air for their life support.
Look, making fuel and oxygen on Mars it's revolutionary. But it's really just the beginning. ISRU completely opens up the playbook and changes how we think about exploring space.
Because ISRU isn't just for making gas for your rocket. You can use the same ideas for so much more. We're talking life support, making your own air and water. We could use Martian dirt to 3D print landing pads or even buildings. We could make spare parts, set up solar panels, basically learn to live and build using what's already there.
And this whole living off the land strategy, it's not just a Mars thing. You could take these same technologies and adapt them for the moon. Or maybe you go mine resources on one of Mars's moons, like Phobos. This is really the key. It's how we unlock a truly sustainable human presence pretty much anywhere in the solar system.
And that leaves us with one last incredible thought to chew on. For our entire history, we've been tied to Earth. We could only go as far as the resources we could pack with us. But if we can truly learn to live off the land on other worlds, well, the question stops being if we can go. It just becomes, where do we go next?